Hello everybody. I'm presenting a problem in geometry or a problem in maths which we can call a conic section. Conic section. Conic section problem. I have a problem statement here. And my objective is to solve this problem. And what does the problem say? It says, find the center and the radius of the circle. The center and the radius of the circle. It is very amazing in mathematics how you can use this expression. X squared plus y squared plus 6x minus 4y minus 3 equals to 0 to represent a circle. It's very amazing. Why do we have to use x and y? Two variables to represent a circle. Remember how you make up a circle? You make up a circle in the following form. You go back to your what? 2D plane, Cartesian plane. This is the y-axis. This is the x-axis. You can make up a circle as this. Now, this point is the center of the circle. Wow, this is the radius. That's the radius. And this is the what? Center point. And remember, in a 2D plane, a center, a point, is specified by two values, x values, x1, and y values, y1. You can have many points, right? But there's a special point. For a circle, there's a special point called a center. And the center, the distance between the center and the circumference of the circle is called a radius. That's how you can make up, you can derive an equation to represent a circle. So when you have a center point, say 1 and 4, and radius, say 4, this information, this data, it's enough, they're enough to represent a circle. Okay? Now, so you can legally, if you want to be a little bit more detailed or more complex in your definition, you can say a circle is a collection of points x, y, right? From a 2D plane with equal distance from the circumference. Right? You may want to define a circle that way if you like it, but it's a little bit more complex. So look at it. This is the center of the circle. This is a point, a point, a point, a point, another point, and so on and so forth. And each of those points, they are of the same distance from the center. Look at that. These are the radii. Right? That's how you form a circle. And generally, you represent equation of a circle in a standard form this way. X minus x1 squared plus y minus y1 squared equals r squared. X1, y1 is the center of the circle where the point x1 from this expression, y1 is what? Center. Center of circle. Center of the circle. And your r is the radius of this circle. It's the radius of the circle. Okay? So you need a what? Center point and the information about the radius to derive an expression to represent a circle. Okay? Now, keep that at the back of your mind. But we have a problem here. And okay, another thing I want to say, that is what is called a conic section in maths. When you pick up a cone, and you intersect the cone with a plane. As a way you can do that in geometry or design, you will come across what is called conic sections, different diagrams, depending on the angle of rotation of the plane. If you rotate the plane in a certain way, you can get what is called ellipse. If you make it another way, you can get what is called hyperbola. You can get what is called parabola, and you can get what is called a circle. So these four terms, each of them is called a conic section. Conic section. Because each of them can be derived geometrically when you intersect a cone. A cone, see that? It's a cone with a plane. So once again, a circle is a conic section, and it's represented this way, standard form. Okay? All right. So we are picking on this. We have this problem, x squared plus y squared plus 6x minus 4y minus 3 equals to 0. Now, the question you should ask is this. Why can't we have more than two variables in this expression? Why just only x and y? Because normally your circle, 2D circle, is formed from what? 2D plane. And in 2D plane, you have only what? Two variables working together, x and y. So you need the variables x and y, or any other variable. You can call it a and b or m and n. It doesn't have to be x and y, but you just need two variables. One variable for the y-axis, for the vertical axis, and the second variable for the what? Horizontal axis. Okay, but conventionally all over the world, we use y and x. Okay? We use y and x. All right. We use y and x. We use y and x. Now we have x squared plus y squared plus 6x minus 4y minus 3 equals to 0. You see that? Now, this is not looking like this one. I need to transform this equation to look very similar to this standard form. Okay, and first step is I can make, now luckily for me, I do not have non-unity coefficient beside my x squared and y squared. So I don't need to divide, because this is 1, this is 1. But I have to bring x squared and 6x together, x squared plus 6x together, and bring my y squared and the negative 4y together. See that? plus y squared minus 4y, and then I can transfer the negative, the constant, to the right side, equals to what? 3. Now, I'm not done at all. I'm not done. I need my expression to be of this nature, right? Now, the coefficient of x is 6. I will look for half of that. Half of 6 is 3. So I will do x squared plus 3 squared. Now, this is very similar to method of completing the square in quadratic equation. But the reason why I'm doing this is because I'm moving from here to here because I want my equation to look similar to this one. You see that? Now, if I expand this bracket, I'm going to have x squared plus 6x plus 9. I don't need extra 9. It's not, in fact, this expression is not exactly this, because if you do the expansion of this, you're going to have x squared plus 6x plus 9. It's giving me extra variable, extra number called 9. So I need to remove that 9 from the expression. That's when it is exactly the same in value with this. So this expression here and this one, this expression here and this one are exactly the same thing, but in different form, so that it can look like what I had here. Okay, so this similarly, I'm going to come to the second variable y. The coefficient of y is negative 4, so the half of that is negative 2. So I'm going to do, I have a plus here, so bring the plus here, so y minus 2 squared. Now, if I expand this guy again, I'm going to be having y squared minus 4y plus 4. This is a trouble for me because I have additional 4, additional variable, number, constant, being added to it. So I need to remove that number away from that. Now, at this stage, this and this is now the same thing. Okay? So perfect. So what I have at the left side here and here, 1, 2, 3, 4, and everything here is the same. Okay? And then equals to my 3, right? I can transfer the negative 9 and negative 4 to the right side. Okay? Both of them to the right side. Now I will have x plus 3 squared plus y minus 2 squared. When my negative 9 gets to the right side, it becomes plus 9. When negative 4 gets to the right side, it becomes plus 4. So I have x plus 3 squared plus y minus 2 squared equals to 16. I'm not done yet. Okay? Now, look at what I have here. The standard form says x, the general variable, minus x1, x. But I have plus here. For me to get plus here, this has to be what? X minus 3 squared. Then y, so I have my y here, minus plus 2 squared. 16 r squared, I can express my 16 as 4 to the power 2. Why am I doing all this? Because I know that from the equation, I should have x minus x1 squared. So x minus, so my x1 is now negative 3. See, x minus x1. So x1 is negative 3. Then y minus y minus plus. Why am I doing minus plus? Because I knew originally this is the final, what I had originally. minus. It's only minus plus that can give me minus. And I wouldn't do plus minus because that doesn't make sense. You want to follow the original expression here. So this is minus, so you have to do minus plus. So y minus minus. So your y1 is plus 2 or 2. You can just say 2, right? And r squared, 4 squared. So your r is 4. So you can say here that the center of this circle is the point x1, which is -3, and y1, 2. And the radius of the circle is 4. So that is the solution, okay? So you need the radius is a measure and a point called center to accurately derive equation of a circle. If you have your graphing calculator, you can do the same thing. You can plot and you can represent, you can sketch this graph. You can sketch this graph, this circle. Now look at it. I have x to be -2, -3, y to be 2. Okay? So 1, 2, 3, -1, -2, -3. So x is -3. See that? x1, y1. Y is 2. So y is 2, 1, 2. So -3 to 2. -3 to 2. That is center of the circle. See that? And then you draw your circle around that. And this is the radius. R is 4. And this is the center. -3. That's the circle. So if you pick up your graphing calculator like Desmos and you type this equation, it's going to graph it exactly this way. Okay? So this is how to find the radius and center of the circle from a non-standard algebraic expression. I hope this is very informative. Clap for me.